If x multiplied by x plus 2 multiplied by x plus 4 multiplied by x plus 6 is equal to 6, what is x? We will analyze this equation both algebraically to find the roots quickly and graphically to better appreciate the problem. Now, the equation is x multiplied by x plus 2 multiplied by x plus 4 multiplied by x plus 6 is equal to 9. Expect 4 roots as this is an equation of the fourth degree. Rewrite the left hand side as x multiplied by x plus 6 multiplied by x plus 4 multiplied by x plus 2. Now multiply the first two terms and the second two terms to get x squared plus 6x multiplied by x squared plus 6x plus 8 is equal to 9. Substitute y is equal to x squared plus 6x to get y multiplied by y plus 8 is equal to 9. Or by rearranging terms, y square plus 8y minus 9 is equal to 0. This is a quadratic equation in y, so we can get two roots by following the general formula for the solutions of a quadratic equation, which is if the equation is ay square plus by plus c is equal to 0, then y is equal to minus b plus or minus square root of b square minus 4ac by 2a. A, b and c are the coefficients of the square term, the linear term and the constant term. In this case, a is equal to 1, b is equal to 8 and c is equal to minus 9. Therefore, y is equal to minus b, that is minus 8, plus or minus square root of b square, that is 64, minus 4 into 1 into minus 9, that is plus 36, divided by 2 by 1, that is equal to 2. So, by simplifying the term under the square root, we get 64 plus 36 is equal to 100. Square root of 100 is 10. Therefore, y becomes minus 8 plus or minus 10 divided by 2, that is 1 or 9. Let us analyze it case by case. Case 1, y is equal to 1. If y is equal to 1, then remember we had substituted y is equal to x square plus 6x. Therefore, x square plus 6x is equal to 1, or x square plus 6x minus 1 is equal to 0. Again, this is a quadratic equation in x and the roots are minus b plus minus root over b square minus 4ac by 2a, and in this case a, b, c are a is equal to 1, b is equal to 6 and c is equal to minus 1. Therefore, we get minus 6 plus or minus 36 plus 4 square root of that divided by 2, which is equal to minus 6 plus or minus square root of 40 divided by 2, that is minus 3 plus or minus square root of 10. In the second case, y is equal to minus 9 or x square minus 6x is equal to minus 9. Hence, x square plus 6x plus 9 is equal to 0. Or x plus 3 whole squared is equal to 0 because x square plus 6x plus 9 is x plus 3 whole squared. Therefore, x is equal to minus 3. Note here that because this is a squared term, x plus 3 whole squared, there are two roots for x and both are coinciding at minus 3. So, in all, instead of 4 roots, we have 3 roots. X1 is equal to minus 3 plus square root of 10. X2 is equal to minus 3 minus square root of 10. And x3 is equal to minus 3. Remember that x4 is equal to minus 3, but since x3 and x4 are the same, we are only mentioning one root. And if we take the square root of 10, we get x is equal to 0.16228 approximately. Then it could be minus 6.16228 approximately and minus 3. These are the three. Before going any further, please like, subscribe, share and hit the bell so you can be immediately notified for new uploads. It is completely free and only takes a few seconds, and you can always unsubscribe later if you do not like my videos. Therefore, kindly like, subscribe, share and hit the bell icon now. Without further ado, let's proceed with the rest of. Let us now analyze the problem graphically. The given equation is again x multiplied by x plus 2 multiplied by x plus 4 multiplied by x plus 6 is equal to 9. Again, this is a fourth degree equation in x, so 4 roots are expected. Consider the LSS, that is left hand side. This is positive for all positive values of x. For x is equal to 0 or minus 2 or minus 4 or minus 6, the left hand side becomes 0 because one of the terms in the left hand side becomes 0. So, no roots exist for these values of x because the right hand side is 9 and 9 is not equal to 0. Again, for all positive values of x, the left hand side is positive. For x is equal to 1, left hand side is equal to 1 multiplied by 3 multiplied by 5 multiplied by 7 is equal to 105. So, the left hand side will reach the value of 9 for a value which is more than 0 but less than 1. So, therefore, we expect one root of the x in the range of 0 to 1. For negative values of x, left hand side can become positive or negative depending on how many terms are negative. If 2 terms on the left hand side are negative or 4 terms are negative, then their product in the left hand side is positive and some roots may exist in these cases. But if one or three terms are negative, the left hand side will be negative and there will be no roots. Now let us examine the negative values of x in different ranges. When x is between -2 and 0, only the first term is negative. When x is between -4 and -2, then the first and second terms are negative. If x is in the range of -6 and -4, the third term is negative. The first and third terms are negative, and in the range -infinity to -6, all four terms are negative. Since there could be solutions when two terms are negative or all four terms are negative, we have to look for solutions in the second case and in the fourth case, not in the first case and not in the third case. The graph of the left hand side, that is red, and right hand side, that is black, is drawn here using a graphing calculator. In this case, the left hand side is equal to +9 at three values of x. These three values of x are plus 0.16228 or -3 plus square root of 10 and -3.0, and here two coinciding roots occur, and the last one is at -6.16228 or -3 minus square root of 10. I am enlarging the graph so that you can see it properly. This red one is the graph of the left hand side, and this one is the horizontal graph of the right hand side, that is y is equal to 9. Now the red graph and the black line, they intersect or touch at 3 points. One is here, 2 points are here, one going up, one coming down, and the third point is here with the coordinates we have already described here. So these three are the roots of the given equation.